Function transformations. A function transformation changes the appearance of a basic parent function by stretching, compressing, and shifting it on a graph. A parent function is the simplest form of a family of functions. For example, the simplest quadratic function is y equals x squared. The first type of transformation is the vertical shift. The mathematical formula used to express vertical shift is y equals f of x plus b. If b is positive, it shifts the graph up. If b is negative, it shifts the graph down. An example of this is the parent function y equals the absolute value of x changed to y equals the absolute value of x minus 3, which shifts the original graph down 3 units. The same goes for the parent function y equals x changed to y equals x plus 7, which shifts the original graph up 7 units. Another way to look at vertical shift is graphically, starting with the graph of parent function y equals x, which passes through the origin. When you change the function to y equals x minus 2, it moves down 2 units and crosses the y-axis at negative 2. If you make the 2 positive, it moves up 2 units and crosses the y-axis at positive 2. The second type of transformation is the horizontal shift. The mathematical formula used to express horizontal shift is y equals f of x minus a. If a is positive, it shifts the graph right. If a is negative, it shifts the graph left. An example of this is the parent function y equals the square root of x changed to y equals the square root of x plus 5, which shifts the original graph left 5 units. The same goes for y equals x squared changed to y equals x minus 2 squared, which shifts the original graph right 2 units. You can also look at horizontal shift graphically, starting with the graph of parent function y equals the square root of x. When you change the function to y equals the square root of x minus 3, it moves right 3 units along the x-axis to positive 3. If you make the 3 negative, it moves left 3 units along the x-axis to negative 3. The third type of transformation is horizontal stretch. The mathematical formula used to express horizontal stretch is y equals f of x divided by q. Q represents the function being multiplied by a fraction between 0 and 1. Smaller fractions means functions are less steep, and larger fractions means more steepness. Another way to look at it is bigger q means less steep, and smaller q means more steep. An example of this is if the parent function y equals x squared changed to y equals x squared divided by 5, which reduces the graph to 1/5 of the original steepness. The same goes for y equals the square root of x changed to y equals the square root of x divided by 3, which reduces the graph to 1/3 of the original steepness. You can also look at horizontal stretch graphically, with the parent function y equals x squared changed to y equals 1/2 x squared. It reduces the graph to 1/2 the original steepness. The fourth type of transformation is vertical stretch. The mathematical formula used to express vertical stretch is y equals p times f of x. P represents the function being multiplied by a number greater than 1. Bigger numbers means functions with more steepness, and smaller numbers means less steepness. An example of this is the parent function y equals the absolute value of x, changed to y equals 6 times the absolute value of x, which increases the graph to 6 times its original steepness. The same goes for y equals x changed to y equals 8 times x, which increases the graph to 8 times the original steepness. You can also look at vertical stretch graphically, with the parent function y equals x squared changed to y equals 4x squared. It increases the graph to 4 times the original steepness. Some functions can be transformed more than once. For example, the parent function y equals x squared changes to y equals x minus 2 squared plus 5, which shifts the original function right 2 units and up 5 units. The function y equals x squared changes to y equals x squared divided by 4 plus 9, which results in a horizontal stretch of 1/4 the original steepness and a shift up 9 units. The function y equals the square root of x changes to y equals 3 times the square root of x minus 7, which results in a vertical stretch of 3 times the original steepness and a shift right 7 units. Function transformations come from analytical geometry discovered by French mathematician René Descartes, who is responsible for the Cartesian coordinate system that created a method for expressing geometric shapes on a two-plane coordinate system.